y, so that t seconds after leaving x, its speed v meters per second is given by this particular equation. The term below shows some values of t and corresponding values of v. Find the value of a and of b. I think this one is okay, right? It's just like our normal graph questions. Right? Then using a scale, they give the scale, draw the graph. Okay? So I'm going to show you the graph while you refer to the question. Alright? Now, when the graph is drawn, it's like that. Can you see it now? Okay? Now, we can expect this because it's a quadratic graph. Can you see? But mind you, the vertical axis is what? Is v, meters per second, and this one is what? T seconds. Usually we put the units in brackets. Understand? Okay, I don't know what you do in physics, but in maths we put it in brackets. Okay, so can you see the line? I mean the curve is drawn. Okay, let's look at the first question. Oh, look at the first question. Use your rough estimate the value of t when the speed of the particle is 10 meters per second. 10 meters per second. Now, let's look at 10 meters per second. Now, I must tell you this common mistake as learning. Once they touch, they think this is the only solution. Is this the only solution? Can you see that I can go on, there's another 10 meters per second? So there are two answers. Understand? So you read the answer, they read and they give you the 2t answers. Okay, next part B. The time at which acceleration of the particle is 0. Now this is the speed time graph. Acceleration 0 means like that, right? Horizontal, right? With the 0. So this is the t, so it's 2.1. 2.1. 2.5. The green class, 2.5. Okay? Now, next. Next, what do they ask for? The gradient at t equals to 4 and explain what this value represents. Now, at t equals to 4, look up. It's here, right? They draw a tangent, then you identify 2 points and get the gradient. Now, this gradient will represent what? The acceleration at when t is equals to 4. Understand? Okay, you have to explain. Alright, let's take a look at the answers. Okay, gradient is this amount and it's the acceleration. Alright? Okay, last part, part B. The time interval when the speed of the particle is less than 15 meters per second. Okay, all of you look, this is the one that is not the same. 15 meters per second is here, right? Can see it? Okay, let me give you another color so you can see. Can you see 15 meters per second is this time? On top is greater, right? Below will be less than, right? So what's the time interval? Will be from here to here, right? Can you see it? So what's the time interval? Can you look at the time interval? Can you see it's between what? 0.35 and 4.65. Now, what if I say it's 15 meters per second or less? The first part says less than, right? The question says less than 15. What if it's 15 meters or less? Then you have to have input. Understand what I'm talking about? So it's very tricky down here. Understand? Can or cannot? Yes or no? Okay, so you got to make sure your inequality sign is correct. Okay, so this is the on the velocity speed time graph. Are we okay? Are we okay? Okay. Now what if I change the question? I want the time whereby the speed is more than 15 meters per second. There will be this side, right? Alright, and this side, right? But when you give this side, right, you will say t less than, what is that, 0.35, but you must also qualify one thing. What should you qualify? It must be bigger than what? 0. Because time cannot be negative. Do you understand what I'm talking about? Yes or no? Especially for the end. You cannot just say t less than 0.35. Then it can be other things, right? It can be negative 1, then be negative 1. Of course cannot. So you must qualify this. Understand what I'm talking about here? Okay? function. Okay? Step function. Okay? Now, step function, you cannot say everything also can step function, no. Okay? Let's take a look at this particular question. The step function graph below shows the local postage rates for letters, postcards, and small packages offered by company A. Alright, all of you look here. Let us interpret this step function. All of you look. Step function can only occur for a certain situation. It's not everything can step function. What does it mean? When it is 0 to above, this one is what? 20 rand. They will charge this amount. You can see? You can see it? What does this hollow circle represent? Exclude, right? What about the solid circle? Include. Now, can you see that when it's included here, it must be excluded there. If not, they cannot be too pricey. Do you understand what I'm talking about? Okay, now, then what does this mean? For this range of mass, right, they are charging 50 cents. Can you see it? 50 cents, okay? Now, I can give you another situation where there's a step function. You know, parking lot, last time they used coupon, right? You know, 10 coupon and so on. There is park for every half hour. This is called park thereof. If you read some textbook, they will tell you park thereof. Now, what do you mean? Every half an hour, let's say they charge 50 cents. Understand? Now, what if I park for 40 minutes? It's $1, you know. That means this is, what 60? What should we do? This is 30 minutes, right? 40 minutes is 30 minutes plus 10 minutes, right? This one is first block, 50 cents. This one they don't care how much, as long as you extend it cost consider one block. That's why it's also 50 cents. Do you understand? This is called park thereof. Park thereof means you don't care. Once you exceed, consider the whole block. Understand what I'm talking about? Now, what if this person parked for 31 minutes? It's also $1. You understand? So sad, right? So sad, okay? That's why it's very sad, sad. Oh? Understand? Can or cannot? Okay, so this is called park thereof. So if you read a textbook and they tell you park thereof, it's the meaning of it. Everybody clear? Okay? Alright, now let's take a look at this postage. Okay? Now, the question says, how much would it cost to mail a letter with a mass of 80 grams? Where's 80? 16, 70, 80. So here. Here, right? How much is it? 50 cents, right? Hey, I'm talking to you. Oh, you so called. Is it 50 cents? Okay, good. So the answer is 50 cents. Alright? Now, next. Is it 50 or 60? My God, they answer 50 cents, correct? Okay, now, then let's go at company B. Company B offers the following postage rates. 60 cents for the first 50 grams, okay, and 0.2 cents for each subsequent gram. Given that Shuven wishes to post a letter with a mass of 150 grams, insert the graph of company B's postage rates and determine which company offers a lower postage rate. Okay, now we will add the company B graph here. Yes? Yeah. Now, all of you look here. This is company B's rate. For the first 50 grams, they charge how much? Look at company B. Talking to you. Huh? 60 cents, right? So you go here straight until 60, right? Until 50, right? Sorry. Okay? Now, this is not what I'm worried about. The horizontal part, you should be okay. Alright? It's the vertical part or the starting part that I'm worried about. All of you look at the rate. Okay? 60 cents for the first 50 grams. For first 50 grams. Everybody okay with this straight part here? Okay, right? Now, then what did they say? 0.2 cents for what? For what? Each subsequent gram, right? each subsequent gram. Okay, all of you look. Can you see this one is 50? Okay. When I reach 150 is 100 grams, right? Alright. You don't go and talk per gram, you will die. Okay, 100 grams. So, may I know 100 grams will cost how much? 0.2 times 100, right? So how much is this? How much is this? 20 cents, right? Everybody okay? So that means at 150, it must be 80 cents, right? Correct? Okay, so 150, it must be 80 cents. Can you see? Then you just draw a line like that, all the way up. Everybody clear? Everybody clear? You must look for a certain range. You don't just go and talk gram by gram, you will die. Everybody clear? I'm talking to you. Why are you still talking about geography? You want to do geography now, you will get out of the class and do us. You want to do geography now? Okay, good. So do you understand what I'm talking about here? Yes or no? Okay, then they ask, Schumer wants to post something that is 150 grams. Okay, which one offers a lower postage? Okay. 150 grams is where? Here, right? Go up. Now, what happens? The two graphs intersect, right? That means both company is equally good. Agree? Agree? Now, then I want to ask a question. What if I want to post 100 grams? Which one is cheaper? If I want to post 100 grams, which one is cheaper? A, right? Can you see? What if I want to post 250 grams? Also A cheaper. Understand? But can you look at this whole thing? When is A more expensive? Can you see it's this part? Because it's above this line. Can you see it? It's this part that A is more expensive. So you must be able to analyze the step function. Are we okay? And very often they want to insert the line for another company and get the intersection. Do you understand here? Can or cannot? Cannot. Okay, good. So that will be your graph. Now the last graph that I'm talking about is actually quite simple. It's the battery life one. Oh, look at the last one. The graph below shows the battery level of a smartphone. It had an initial level of 20%, okay, which then increases to 60% in half an hour while connected to the power supply. Then removes the smartphone from the power supply to watch the 20-minute long video clip. Then before reconnecting the smartphone to the power supply. Okay, find the battery level of the smartphone when Wei Ming was halfway through the video clip. Now, where did he watch the video clip? It should be here, right? Agree, class? Because it's decreasing. So halfway will be here, right? Agree, right? So how much is it? 40%. 40%. How many percent? 50, yeah? Is it 50? No. Is it 50? Yes. Down here, right? 50%. Okay? Now, next thing. The question says, find the rate of increase in the battery level of the smartphone when it was later reconnected to the power supply. Now, which one was the later connected to the power supply? Is this part correct? Correct. You just find the gradient here. Understand? Okay? So, you just choose two convenient value and then you find the gradient. Okay, if you look at this point is a 90, 100, right? Correct. What about this point? This point is what? 50, 40. So, I will have 100 minus 40 over 90 minus 50. 60 over 40, right? Correct. So, this is a 3 over 2, right? Correct. Or 1.5% per what? Per minute. Are you all okay? 1.5% per minute. Are we all okay here? So that's how we get the answer. Is everyone clear with what I'm saying? Stop Okay? I gave you some questions to try, right? In the notebook yesterday. I'm going to go through them now. If there are no problem, I'm going to straight away do the homework together with you. Okay? Now, first question. Question 4. Any trouble? Got trouble, please raise hand now. If not, I will just think that you have no trouble and then I will just carry on now. Are we okay with question 4? Yes, good. Question 5? Are we okay with question 5? No hands? Okay. Alright, good. Next one. Question 13. Are you okay with 13? I'm talking to the class. Are you okay with 13? Yes? Okay, good. 17. 17 is somewhat the same as the exercise that I've gone through just now. Example, okay, 18. 18 is also okay, right? Though it looks very complicated, but it's fine, right? Correct? How about 19? 19, shall we check your block? Okay? I'll work down and show you your block. Because since everybody got no problem, right, at least we have plotted them out. Show me your block. Take out now. Don't be shy. Realize that I didn't score. Okay? But those people who didn't do all the work, can you go back to it? It is practice for you. Do you understand? I don't choose questions for no reason. I chose it because it's important. Do you understand? Okay, let's take a look at the first one. Okay? The diagram below, okay, shows 3 containers of a fixed volume and varying cross sections, each with a height of 8 cm. The containers are initially empty. Each of the containers was then filled with water by the same tap at a constant rate. When given that it took 60 seconds to fill each container, sketch the graph of the height each cm of the water level against time t seconds for each of them. Now, I'm going to do the first one. I told you to ignore the dimension, right? I just want the shape. Okay? Now, first one. The height will be in cm. What about the time? It will be in seconds, right? Now, the first one, can you tell me, is slow first, then fast, right? Correct? So, it will be slow first, then fast, right? Correct, straight line. But, what is the end point? Can you tell me? This must be what? 8 cm. How much is here? 60 seconds. Is that clear? I already wrote cm, so this is just 8. Understand? Do you have this? How many can get this? Okay, good. Next one. Okay, next one, height in cm, then time in seconds. Now, what is here? This is uniform, right? So it will be a straight line, correct? Now, what about here? Slow to fast or fast to slow? Fast to slow. Okay. So it will be a straight line. Then after that, you will go like that, right? Now, of course, it will not come down, it will reach. Understand? So this will be your 8, and this will be your 60. Okay. Everybody clear? A lot of people, when I set this type of question, like this, forget to label 8 and 60. Okay, then I will read out the rush. Okay, last one. Let's take a look at the last one, okay? slow, fast, right? Correct. Slow, fast, right? Fast, slow, right? Agree, right? So, slow, fast will be like that, right? Then fast, slow will be like that, correct? Yes or no? Now, there must be a difference from here and here. This is a straight line, while this is a what? What is this? This is a convex curve. Do you understand what I'm talking about? There must be a difference. If not, it doesn't make sense. Follow with what I'm talking about? Yes or no? Okay, Alright, good. So, basically, can you all get the idea of the water flowing into the container? Okay, Alright, good. Now, next one. Okay, what number is it on the content page now? May I know? What number is it on the content page now? Now what do I write? I write nothing. 14. 18. Okay, all of you write 18. Today's date, which is the 11th. Exercise 5C. Is it 5C? Okay. Brush in real world context. I'm going to tell you what I want to do. Okay? I'm going to do question 3. Question 7. Question 9. Question 12. And question 16. 8. Are we okay? Are we okay? Now, I want to do question 3 with you first. Okay? I've got how many questions altogether? 1, 2, 3, 4, 5. Okay. Now, hold on. I want to do question 3 with you first. Is that okay? Okay. All of you go to question 3. Take out one piece of foolscap paper first. Let's look at question 3. Okay, let's look at question 3. After that, right, I will tell you what to do. Now, the figure shows the distance time graph of a car. Okay? Find the duration during which the car is not moving. Have you taken down the questions already? I'll wait a while. Because later I'm going to give some instructions and then you're going to plot some graphs for me at home, okay? I'm going to do those without plotting first. Alright? Are we okay? Taken down? Okay, good. Now let's take a look here. What did they say? This is a distance time graph. Find the duration at which the car is not moving. So 3 part 1. What's the duration that is not moving? When time is what? 1.5 to what? 2.5. Yes. So can we write down the answer? The duration will be, it's not the timing, it's the duration. So it's 1.5 to 2.5. How many hours? From here to here, what's the duration? How many hours? 1 hour. So everybody okay? Now what if I say from what time to what time, then how? 1.5 hour to 2.5 hours. Okay, duration is the amount. Okay, just like the duration of the paper is 45 minutes. Alright, now next. Part 2. Find the average speed of the car in the first 2 hours of the journey. Find the average speed. Now, what is the total distance traveled for the first 2 hours? What is this? 60. 60 what? Kilometers. So, total time taken is 2 hours, right? So, what speed, right, is total distance divided by total time. It includes rest time. You understand? You do not deduct away the rest time. Understand? Oh. Total time taken. Okay. What's that? Total. Wait. I write 2 times the time. Total time taken. Okay. Okay? I repeat one more time. Average speed is total distance divided by total time taken. It includes the rest time. Understand? You don't deduct away the rest time. Everybody clear? Okay? That means for the whole journey means, let's say they stop at the kiosk and buy something, or they stop at the red light traffic. Okay? So it's also considered. Understand? Okay? Alright, now next. Find the average speed of the car for the whole journey. So part 3. Whole journey. Can you tell me what's the total distance traveled for the whole journey? Look at it. 120. Very good. What is the total time taken? 3.5. Am I right? Is it 3.5? Okay, use your calculator. What's the answer? 3 what? Give me whole number. No, fraction. 34 what? 34? 2/7 kilometers per hour. Are we all okay? Are we all okay? Alright. Actually these 3 parts I expect no problem. It's the last part that I'm worried about. Because in O levels, right, they can give you distance time graph, ask you to convert to speed time graph. Or they give you the speed time graph, ask you to convert to distance time graph. You understand what I'm talking about? Oh, that is the difficult part. Okay. Can I clear up all this? Because I find that all these are quite simple, right? Okay. First of all, I want everybody to do this one. Because this is important. Can you all use your pencil and your ruler? Can you draw the distance time graph? Sketch only. No need to be in scale. First, listen to me first. Then you draw another one. Speed. It must be in line. Do you understand? I want you to know how to convert each section down. Do you understand? In O level, they will give you in line also. Understand? So what you do is that from 0 to 1.5, this is 60. You go this way. Then 60 to, this is 2.5. This is horizontal, right? Then from 2.5 to 3.5. It goes to where? 120. So, can you do the sketch for this part first? Then I'll tell you how to translate it to speed time. I just want the major points. Are you okay? Yeah. Then I'm going to translate part by part. Okay. Once you're done, you look forward. Alright. Can you look at this first part? This part, May I know what is the speed for this part? 60 divided by what? 1.5, right? Correct. So what's the answer, focus? 40, right? 40 kilometers per hour. Do you understand? I'm talking to you. Do you understand? Okay. So don't draw first, listen to me first. So this part will be 40 and it's constant speed, right? Do you agree that when it's a straight line on a distance time graph, it's constant speed? That means this will be constant like that until you reach what? 1.5, right? I'm talking to you. Are you all okay? Can or not? You must know how to translate this. Okay? Now, next. The next part. Here is what? The speed is 0, right? Because the object is not moving. Am I right to say that? That means from here, this is 0 here. Can you see what I'm talking about? Sorry about the thing because I cannot draw too small. Okay, now what about the last part here? What do you think will be the speed for this last part here? 60 divided by what? Because this is 1 hour, right? 60 divided by 1, so it's 60 kilometers per hour, right? So it will be higher. Agree or not? From 2.5 to what? 3.5. So it will be 60. One straight line like that. Do you understand what I'm talking about? Can or not? Can or not? Okay? Now then from here I want to teach how to translate back. You understand? You not just know how to come to speak, then don't know how to go home. Then that's very bad. Clear? Everybody okay? Right, take down first. No need. You don't draw the vertical line. You just draw like that. Okay? Because if you draw vertical line means the speed suddenly boom. You get what I mean? But it's theoretically it's like that. In real life it's not like that. You got to slow down first before they come to rest. Do you understand what I'm talking about here? Yes or no? Okay? Can? Are you okay with the translation? Can or cannot? Can, okay, now, what if in the exam they give you this, they want you to draw this one. Then how? Then you look at this area, right? Area under speed time graph is what? Distance, right? 40 times 1.5 is 60, right? And this is a constant speed. Can see it now? Okay, talking to you. Constant speed. So, see? Constant speed until 60. Understand? Then, 0 speed. That means not moving. Like that. Understand what I'm talking about here? Then, you look. What's the distance traveled here? 60, right? So, from here to 3.5, another 60. So, 120. Can you see? I can translate up. You understand what I'm talking about? I chose this because it came out before. And what's worse, they didn't give straight line. Okay? They gave curve for the speed and so on and so forth. So we must know how to translate. Understand? That means there's an acceleration or something. You understand what I'm talking about? So you must know how to translate the simple one first. When I come across that question again, you will do it in series. Everybody clear? You must know the basic. How many of you are okay with this? Can you understand? Can or cannot? Can, okay, good. So that is your question 3. Now, I want all of you now to look at question 7. And all of you look at question 7. Okay? Now, for question 7, it says so on and so forth. You're supposed to use the scale, okay, and draw. And then you just draw for me, okay? On the graph paper, okay? Okay, you cannot answer the questions tomorrow, you come and answer. If you can, please answer them. Everybody okay? So question 7 is done. Question 9. Okay, question 9 I'll hold on first. Question 12, you just need to sketch that diagram and then answer the question. This one to be done on the foolscap paper. Understand? 7 on graph paper, 9 on graph paper, and 12 on the foolscap paper. Understand what I'm talking about here? And the last one is question number 16. Can you see the scale is also given to you? You just draw and answer accordingly. Okay? But I want to show you question 9. I want to give you the scale. Okay, so I'm going to write down here, in case some people don't know what I'm talking about, right? Foolscap is question 3 and question 12. Graph paper is question 7, 9, and 16. Are we clear? So you're going to have 3 graph papers. Everybody okay? Can or cannot? Can. Okay, I'm going to talk about question 9 first. I'm going to give you the scale. Okay, question 9. I lost my question 9. Yes. Okay, I want you to have this up. Let me put a white color over there. Okay, question 9, I want this. This is distance in kilometers. This is time. Okay. I want to add distance from Cheryl's house. Kilometers. Okay. Distance from Cheryl's house, kilometers, and then the time is just the normal timing, there's no units. So this is what I want to do. 5, 10, 15, 20. Then this is 0900, 10, 11, and 12. I'll give the scale. This one is 2 cm, understand? 2 cm. Now, how about this? This one is 4 cm. Will that be okay? Can. Then you draw the graph. If cannot, tomorrow come back, we do it again. Everybody clear? Okay, I repeat. 3 and 12 on graph paper, 7, 9, 16 on graph paper. Okay, nonsense. 3 and 12 on foolscap paper, graph paper 7, 9, 16. Everybody okay? Draw the table at the back of the graph paper. Okay, now when you staple the foolscap first, followed by the graph paper. Everybody clear? Can or cannot? Talking to you. Okay, good. One day stop the video.